What's up? Sorry? Alright, yes, do that. Cool. Alright guys, so let me catch up to you here. So what do you guys get for this first one here? 2d minus 3. Kick ass, because you can put the d's together. And the poor little minus 3 is all by himself.
Bring it down. Bring
it down. Alright. What about this guy? Does this guy have anybody to go with? Yes. So 5xy minus 8xy, yes? Say again? I'm sorry? Yeah, we sort of worked on some of these together. Yeah, don't worry about that part. Okay. Yes, alright. So 5 of these minus 8 of these is negative 3 of these.
She just said she just did it the other way around. This is still possible.
Alright. So what about this guy? Cool. So negative 2x minus 6x. Negative 8x. Good. Don't say to yourself 2 negatives make a positive. That's only if you're doing what? Multiplying. We all know too well when you put debt together with other debt, it's still debt. It's just more debt. And then who's by himself? Fullness. Okay. So what about this guy? What are the? How many like terms are there here? 2. This guy, this guy. What do you get when you put those together?
11.
And who are my leftovers?
You wouldn't cube it?
I wrote it
No?
2 different ways.
Oh, sorry. I was trying to figure out who's talking to me. What's up?
You wouldn't cube that.
All right, I love it. All right, you ready? Exponents are based on what operation? Like if I said what's... No, if I said what's 3... Guys, focus, yes, on me for right now. 3 cubed is what? What do you do in your head? What do you do?
Multiply.
Multiply. So exponents are based on multiplication. Therefore, they will only change if I am multiplying or dividing. Adding, subtracting, what changes are the coefficients. Because coefficients are based on addition. It's crazy. So if you give me, if you said right here that there was a w cubed, I'd say there were no w cubes at all to begin with. How did you create them? Do you see what I'm saying? There's a collection of w squares, and then there's some w's and some ones. There's minus 3s and 1s, right? So that's all I should see in the answer. There's absolutely no w cubes there, so there can't suddenly become some w cubes now. You guys understand? With that said, oh yes sir.
Why is the 11 first?
It doesn't, at the moment, it doesn't completely matter, but I do, with polynomials, guys,
I got the equation right, but I got it mixed
with
up.
polynomials, I want to start making you understand that descending order is the normal way. You do the highest powers to the lowest power. But for right now, if you put, what did you say then?
I had 5w plus 11 2w minus
W squared minus 3. Beautiful. Right now, I'd say that's perfect. But when I write it, I'm going to write it descending order just because it's the way I think. I like it. So later, descending order is going to become more important because that's the standard form of a polynomial kind of thing, right? Right now, all I'm going to check is, did you put the right things together? Yeah. So the homework? Oh yeah, I gotta remember somehow, because you need it bigger, right? I got copies of the homework, they're not like bigger. So I don't know if you have a way to, a magnifier or something to make them bigger. I can give you copies, but bigger. Yes, I'll give them to you. Let me finish this out real quick. All right, guys. So we talked about distributed property before. Now I want to combine it. So this first problem, though, is just straight up. I really feel bad when students tell me, let me write this. This is a mistake, right? When students tell me, okay, here's what this is. This is 5, 6 WM. So that's 30 W. Where the hell did they get 6 WM? Where'd they get that? What'd they do? They multiply. Or the more likely, I get stuff like this. 2 times x plus 3, and the next line says this. Do you see what I'm saying?
What are they smoking?
This happens more often.
What?
If you're going to, you got to bring enough for everybody. Yes. Exactly. So inside, they're making addition become multiplication. So that's concerning to me. That should be. It hurts me on some level to write that.
Oh,
It does. I mean, so what am I supposed to do here? 15W minus 10M. I love it. Kabam. Just ma'am. Here, what actually matters a little more is if there's a negative, I normally like to put it internal, so it's harder to lose. So I'd rather put the positive one first. You know what I mean?
Yeah.
Instead of saying negative 7x plus 2y, I'd say 2y minus 7x. It's cleaner. But if you did it, if you turn it around, you're not wrong.
So I wrote the same thing, but I don't remember if you told me in alphabetical order.
That would be sort of like that problem we did with the A, B, and BA. That's where it's more important. Inside of a term, I want them alphabetical so that I can compare them easier. So I don't want C, D, A, and then another one's got A, D, C. You know, they're really the same thing. If only I just wrote them in the same order, it would be the same thing. What about here? This is where people make mistakes. We haven't talked about FOIL method yet. In fact, you guys know what FOIL method is? It's not
Negative ghostwriter.
It's not just a way to bake your potato.
Oh!
Oh, Jeff, you're so funny. All right. So here, what's the only thing multiplying something else, really? I mean, what's the only thing I got to do something with multiplication-wise? 3. You can see why. Do you see why somebody would start doing this? I mean, they think this whole thing, but I would need parentheses around this whole thing, right? The only thing multiplying 2 minus x is the 3. So the 2x just is kind of sitting there waiting. Chilling. 6. Minus 3x, I like it. And now you can put your like terms together? Yeah. Negative x plus 6 or 6 minus x. Yeah. Either one is right. I like it. I'm going to get louder. She's going to get louder. It's going to be this crazy arms race of voices.
You're going to be yelling at the wall.
What the hell's going on?
What the heck, God? I think you might do.
Yes, I'm sorry. Oh,
It's the same thing.
you can. It's just not done. To be honest, do you guys know this? Do you guys know that when I just write x, I actually mean 1x, right? I actually mean 1x to the first. I actually mean 1x to the first over 1. I'm not going to write any of those ones. We just understand they're there. So is it wrong if you do this? Not really, but I'm still going to at least put a note there saying, don't write the 1. It's convention. If I see an x, I know there's 1x. I don't have to write 1. Yeah, cool. All right, so here, what do I have to do?
Okay, what do I can distribute?
Like, I hate it when people start, they put these A's together. Can you see why I can't do that? Where's this 2A currently? It's stuck inside, so that's why I always distribute first. So then all the pieces become able to move around, and then I can put like terms together. So I have to do this first, and I have to do now here. What am I going to take through here? -2 is going to go through. So I get 3 times A, 3A, 3 times 2B, 6B, -2 times 2A, -4A, -2 times -5B, positive 10B. All right, let me stop there for a second. When there's a negative in front of your parentheses, all the signs will change inside. Do you see how the A term was positive? Now it's negative. The B term was negative. Now it's positive because the negative outside changed all those signs. So when you multiply a number by a negative, doesn't that change the sign? Like, what's -5? Now multiply that by a negative. It becomes positive 5, right? So when I have a negative in front of my parentheses, all the signs are going to change inside. Do you have to remember that? No. You just do -2 times 2 is -4. -2 times -5 is positive 10. Are we doing okay with that? Sort of? It's the sort of people that I want to talk to. What are my sort of people? I really want this to make sense. Now just to show you, let me just show you this. I got to get more room to write. Something's blank here. Come here. Where are you at, blanks? Nothing's blank. All right, fine. So real quick, 3A plus 6B, that's great. That's good. Holy crap. Okay. Yes, sir.
Just bring me homework. It doesn't need to be there because I didn't see it just fine.
Oh, okay. Oh, yeah, I'll give you copies, but I got them right here. Now watch. If you brought just the 2 in, that negative is still out there. 2 times 2 is 4. 2 times -5 is -10. But see, that negative is still out there.
I thought it was separating the two, like, that was this subtraction from each side. I don't know. I'm trying to explain.
All right, so here's the thing. If I said, tell me this, what's 7 minus 5? 2. It's crazy. So any number that I put here that is 5, the answer better come out to be 2. Does that make sense? Because 7 minus 5 is 2. So if I put 2 plus 3, the answer better come out to be 2. Right? So what is this subtraction applying to? This whole number. So if I wanted to, so to make this still come out to be 2, I have to change the sign of 2 and change the sign of 3. So this is 7 minus 2 is 5 minus 3 is still 2. This negative sign, what number is this negative sign operating on? This whole thing.
Okay.
So every piece of it will change sign.
Alright, and I get it.
Maybe. So let me do another example, real quick. What's 3 times x minus 7? What's that? 3x minus 21. Now, if I change the sign, that should become negative, and that should become. And how do I change the sign? I put a negative. So if I did this instead, guys, if I did this instead, now it's going to be negative 3x plus 21. All right. Stay with me now. So now watch. Why would that change just because I put something in front? I really want them to make... Are you guys all cool with what I did there? Obviously, negative 3 is going through. Just because I put an 8 or something in front of it, I'm still going to take negative 3 through. And then I'm just going to... There's the 8, just sitting there. I think that's the part that you guys don't quite get. Just because there's other shit here,
Yeah.
I don't care. There's still a negative 2 in front of that.
Alright, I think so.
I'm still going to take a negative 2, and then I'm just going to write that stuff in front, where it is. Just because I put that there doesn't change the meaning of this. I like it.
I still derive the same answer, it's just weird on this one.
Okay, yeah. You'd have to do multi-step weirdness. It's better just to take the whole thing in. Yeah.
So,
Okay.
I'm not quite done with it yet, but
At the end, I got
Okay.
okay.
I was like,
I want to make sure everybody's got this step down.
Yeah, we got it.
I
Now it's just get like terms together, right? So I can get the A's together. What do I get?
-1. Or
negative 1 alpha. Or, yeah. Plus 16 bravo.
That's right. No whiskey tango foxtrot. It's all.
Sorry, ex-military.
It's all right. Whiskey tango foxtrot.
Damn skippy.
All right, how we doing? No? What's up? So what I don't want you to do, number one, what I don't want you to do is compete with me on talking. Hello. Number two is don't just sit there. I see several of you guys sitting there going like, I can't help you if you don't tell me what the trouble is. I can show you other examples, but if you don't either come see me in my office or speak up, if you're not understanding something, there's at least 7 other people that don't also. Yes?
Okay, how did you get the negative A without a number? Since that's 3A and negative 4A?
So what do you think it should be?
I don't know, negative 1A?
Beautiful. But what's 1 times A?
1, I mean A?
A. So you don't have to write the 1.
Okay.
If I ask you how many negative A's are there, you'd say there's 1 of them. I can see it. I don't need the 1 there because just the fact that there's only 1 tells me there's 1. Does that make sense? My grammar wasn't the best, but it was.
Yeah, it does. It
Okay.
makes sense.
Cool. But if you wrote it there, I'm not going to take points off. I'm just going to write this is unnecessary.
Okay.
Okay. All right. Cool. Okay. I don't know if some of you guys have already gotten to the other side. If you have, just sit there for a minute. I'm going to catch everybody else up. Is that still going? Yeah. So I like this idea. When I'm teaching you how to do stuff, it doesn't necessarily have real-world connections immediately. Because that's the problem that students have with math is, how the freaking hell does this have anything to do with me buying gas or whatever? I'm like, how does almost anything have to do with buying gas besides buying freaking gas? So the way to explain how to solve equations can be done several different ways. But where do equations come from? They come from whatever you're looking at. So you got equations that govern the weather. In fact, I know we live in San Diego. We don't get a lot of hurricanes, but I used to live in Florida and Virginia, and we had hurricanes that would threaten and they would actually come ashore and whatever. And we got out of school, yeah. We'd have tape on our windows like the whole hurricane season, just there, just in case. Tape your windows so they don't crash in and kill you. You know, it's a good. I like not being attacked by windows. So you'd see like the hurricane track. I don't know, even if we don't get any, you've all seen that where the hurricane, and then there's like this cone that goes like this is where we think it's going to go. In fact, there's this big. We think it could be anywhere in here, and that's because they have all these different equations. Some of them work at certain times, and some of them work at other times because we still don't know all the variables that affect weather. So when we have equations, they're not complete. But what we do is we have all these different equations, and then they kind of average them all out, and they say, well, it looks like it's going to be somewhere in here. That's the best we could do. And people, for some reason, people actually hear that and say, well, math isn't worth shit. But I'd rather know, well, I'm here, and they're 90% sure it's going to be there, I can feel a little better. Or if I'm here, and they're like 90% sure it's going to be there, I better start doing something. So math at least gets us there. Right? So equations can come from anything that we observe, so we have to know how to solve them. That's my little thing here. What we're going to do is we're going to make an equation not out of observations, because normally those equations are disgusting. We're going to kind of do it like this. I kind of like doing this. Sort of like going along with what I've got on there, the sheet. If I start with a value for x, somebody give me a value for x. 5. So a number is 5. That's what that says. If I add 1 to that number is now 6. Right? So equations are set up with all this stuff being done to my variable. And my goal is to undo all that shit so I can work back to here. So now watch. I could then say, all right, well, what's 2 times the number then? If the number is 6, twice the number is 12. Is that all right? If the number is 6, twice the number must be 12. Are you guys understanding? Okay, I like it. Now, if I wanted to solve that, you can kind of see I would just undo the steps I just did. I could first divide by 2, and then I would be there. All right, so if I divided by 2, I would be there. Shoop. And then I could subtract 1, and then I'm there. So I'm uncovering what the value of x is by taking all the extra layers of stuff off of it, right? That's one kind of strange way of looking at it, but I like that way of looking at it. You're trying to uncover the x. This is not what happens in real life. We don't go, the answer is 20. Now let's add some shit on top and make graphs out of it. No, that's not the way real life works, but we're not in real life yet. We just want to know how to freaking hell to do these equations. So, if I had something like this, m minus 7 is 11. Now I completely understand that when it's really basic, you can work it in your head, but still show me something. Show me something. Show me something algebraic. Yeah. Algebra is doing something to both sides. So, I don't know if you ever heard the idea of this is like a scale. So if I add something to one side, I better add the same amount to the other side so it's still true, it's still equal. So like we did here, if I added 1 to this, I better add 1 to that or else it's not true anymore. I love it. Exactly. Otherwise it won't work. I love it. So how do I get the m by itself? What do I want to get rid of? Yeah, I want to kill the negative 7, so I'm going to, and that's subtracting 7, so I'm going to do the opposite. I'm going to add 7. So then I get, what's left on this side? M equals 18. Now how do I check that? How do I check that? Yeah, put the 18 back into the original. Is 18 minus 7 11?
Correct.
Yes, cool. So I know I'm good. Now, of course, I totally get that a lot of you guys are like, I gotta show that shit for. Yes, because I want to make sure you're being nice to yourself now with the simple stuff, so that when we get to the advanced stuff, you're not doing things that make it harder than it has to be. Because the big mistake people make with equations is they just don't do it in a way that makes it clear to themselves, and they lose parts and they do things in the wrong order. Things just kind of like drift to the other side. The 2 is like, I'll just go over here. And how did that happen? Right? I don't want you doing all this work and getting it wrong. Okay. How does everybody feel so far? I don't know. Again, every single person here has a different experience level with equations or comfortableness with equations. How are we doing so far with what I've done? So let's do another one like that. Let's see a few people with questioning looks. So what about a plus 12 equals 3? What's being done to the a? It's adding 12. 12 is being added to the a. So how do I undo it? Subtract 12. I'm always trying to uncover. I want to undo what's being done to my a. So if I subtract 12 from both sides, there's equals. That's gone. A. A's left alive equals negative 9. Oh yeah. Oh shit. We still got to be careful about negatives and all that stuff. And so if I check it, so if I want to check it, plug negative 9 in, is negative 9 plus 12 3? Yes, 12 minus 9 is 3. Yeah. Kicking the ass in. What's up? That's what you do. It's just what you do. I like it. I like it. So a big part of mathematics is learning new operations and then using those operations in equations. So whenever I learn a new operation, I have to learn its opposite so that I'm able to solve an equation that has that in it. So for example, if I had this, what's the operation currently that's happening to the variable? Is that still going?
Yeah.
Yes? Thank you. Are you about to stop there, buddy? Yeah, I might as well restart you.